Hey there, welcome. If you've ever looked at a block of code and thought it was some kind of secret language for geniuses, I'm here to let you in on a little secret. It's actually a lot more like something you probably already know how to do: follow a recipe. So let's go ahead and open up the cookbook and get started on our very first Python recipe.
So here's the big question, right? Computers are amazing. They're super powerful, but they are also, well, kind of dumb. They're incredibly literal. You can't just hint at what you want or be vague. You have to give them a perfectly ordered, super precise set of instructions to get anything done. So how in the world do we actually do that?
And this is where it all clicks into place. A program is really just a recipe written for a computer. Seriously, it lists out all the ingredients, which we call data, and then it gives step-by-step instructions on exactly what to do with them. If your recipe is clear and correct, you get a perfect result. If not, well, you get a total mess.
Okay, so just like recipes in the real world can be written in English, Spanish, or Japanese, computer recipes, or programs, also need a language. For this first go-around, we're going to choose one of the most popular and, honestly, one of the most beginner-friendly languages out there: Python.
You might be wondering, why do we even need a special language like Python? Can't we just talk to the computer? Well, deep down inside, a computer only understands one thing: machine language. And it's basically just a crazy, endless stream of zeros and ones. It's nearly impossible for us humans to read or write. So, high-level languages like Python act as a translator. They let us write our instructions in a way that feels a lot more like English, and then they handle the job of translating it into those zeros and ones for the computer.
So how does our Python recipe actually get from our screen to the computer's brain? Well, Python uses something called an interpreter, and you can think of an interpreter as a chef who reads your recipe one line at a time. They read an instruction, they do it. They read the next instruction, they do that. And if they hit a step that's confusing or makes no sense, they stop right there and ask for help. This is a little different from a compiler, which would read the entire recipe first, make a list of all the mistakes, and then refuse to start cooking until you fix everything. Python's line-by-line method is awesome for learning because you get instant feedback.
All right, you can't cook without ingredients, right? In the world of programming, our ingredients are called data. This is all the raw information our program is going to work with. It's the numbers, the words, the lists of things that we're going to chop up, mix together, and bake into our final creation.
But wait, where do we keep all these ingredients while we're working? In a kitchen, you'd put them in bowls or jars, right? Well, in Python, we use something called variables. A variable is nothing more than a named container, a labeled box, where you can store a piece of data. That way, you can just refer to it by its name, like sugar, later on in your recipe. Super simple.
And just like in a kitchen, not all ingredients are the same. You've got your liquids, your powders, your solids. It's the same in Python. You have different data types. You've got numbers, like whole numbers or decimals. You have text, which we call strings. You even have collections, like lists of items or dictionaries that store information in pairs. It's just about knowing what kind of ingredient you're working with.
Okay, we've got our language, we've got our ingredients, and they're all stored in their nicely labeled containers. Now it's time for the action, the verbs of our recipe. In programming, these are called operators, and they tell the computer what to do with our ingredients. Add them, multiply them, compare them, you get the idea. Let's see this in action. Say we want a super simple recipe to calculate the area of a rectangle. Okay, step 1, we get our ingredients. We'll store the number 10 in a variable called length and 20 in a variable called breadth. Step 2, we choose our action. In this case, multiplication, which is just an asterisk. And step 3, we combine them all into one clear instruction, or what we call an expression. And boom, the result gets stored in a new variable called area. See? It's just a sentence. All right, our recipe is written. Now we actually have to hand it over to the chef, our Python interpreter, so we can get cooking. And it turns out there are 2 main ways we can do this, and each one is useful for different situations.
So we have 2 kitchen styles here. First up is interactive mode. This is like being a chef who tastes the sauce as they go. You type one little command, hit enter, and Python does it right away. It's fantastic for just trying things out. Then you have script mode. This is like writing your entire finished recipe down on a card, saving it as a special .py file, and then handing the whole thing to the chef to make from start to finish. This is how you build real, complete programs that you can use again and again. So, what happens when you follow all the steps, but the final dish just tastes wrong? It happens.
It happens to every single chef, and it happens to every single programmer. Don't worry about it. The process of finding and fixing these little kitchen mishaps is called debugging, and it's a totally normal part of creating anything.
Generally, you'll run into 3 kinds of errors. First, a syntax error. This is basically a typo in your recipe. You spelled something wrong or forgot a comma. The interpreter literally can't read it, so it won't even try to start. Next is a logical error. Ooh, this one is sneaky. The recipe runs just fine, no crashes, but the final dish is all wrong. You accidentally used salt instead of sugar. The steps were followed, but your logic was flawed. And finally, there's a runtime error. This is when the computer is halfway through the recipe and runs into an instruction that's just impossible, like divide this cake by 0 people. The whole process just grinds to a halt.
You know, it's really easy to get caught up in all the rules and the errors and the syntax, but it is so important to remember that programming isn't just a dry, technical thing. It's actually a creative outlet. As the legendary computer scientist Donald Knuth put it, it's an art form. It's about taking these simple ingredients and instructions and using your own creativity and ingenuity to build something useful, elegant, maybe even something beautiful.
So there you have it. You now get the basic idea. A program is just a recipe. It's written in a language like Python, uses data as its ingredients, and operators as its instructions. You've seen how to write it, how to get the computer to cook it, and even what to do when things go a little wrong. The only question left is, what amazing recipe are you going to create first?